Hello everyone, my name is Baswaraj, 4th year Mechanical, Arrow College of Engineering. This video is about technical seminar on coal gasification submitted to Dr. Mahendra Kumar S, Associate Professor, Mechanical Department, Arrow College of Engineering. Gasification is a process that converts any carbon-based raw materials such as coal into fuel gas known as synthesis gas. Gasification occurs in a gasifier, a high temperature and pressure vessel where oxygen or air and steam are directly contacted with coal to produce syngas. Syngas is further converted into hydrogen and carbon dioxide. When hydrogen is burned, it creates heat and water, which has the ability to create electricity. Hydrogen made from coal can be used for refining oil or used in products such as ammonia and fertilizers, or hydrogen enriched syngas can be used for making gasoline or used as diesel fuel. Gasification is a partial oxidation process which uses only 25 to 40% of the theoretical oxidant. The heat released by partial oxidation provides the most of energy needed to break up the chemical bonds in the feedstock and to drive the other endothermic gasification reactions and to increase the temperature of final gasification products. Depending on the type of gasifier used and operating condition, coal gasification can produce a gas suitable for different uses. A low heating value gas is used for power generation, fuel, and industrial fuel. A medium heating value gas is used for chemical synthesis, and a high heating value gas is used as a substitute for natural gas. Coming to the chemical reactions involved in coal gasification process, gasification with oxygen, or which is also known as partial oxidation, in which carbon reacts with oxygen to produce carbon dioxide. Combustion with oxygen, in which carbon reacts with oxygen to produce carbon dioxide. The next one is gasification with carbon dioxide, which yields carbon monoxide. Gasification with steam gives carbon monoxide and hydrogen. Gasification with hydrogen, which yields methane. The other two reactions, water gas shift reaction, which produces carbon dioxide and hydrogen. Methanation reaction, in which carbon monoxide is reacted with hydrogen to produce methane and steam. Dehydration, any water content of the feedstock evaporates, leaving dry material and the water vapor, which may enter into later chemical reactions. Pyrolysis, in this step, the feedstock is exposed to rising temperature, in which volatile gases such as tar vapor, methane, hydrogen are produced along with some high molecular weight char. Combustion, the volatile products and some of the car react with limited oxygen to form carbon dioxide, carbon monoxide, and provide heat needed for gasification reaction. Gasification, the remaining car reacts with carbon dioxide and steam to produce carbon monoxide and hydrogen. Water gas shift and methanation reaction, these are the reactions which are dependent on the final product and the gasifier. Coal characteristics affecting gasification. Coal characteristics are the most important factors influence gasification process selection and design. Basically, low rank coals are preferable feedstock for commercially available gasification process. The main properties of low rank coals are the reactivity, the moisture and oxygen content, the volatiles content, and the caking properties, the ash characteristic, and the sulfur content. The low rank coals can display over 100 times greater reactivity than from higher rank coal. This increased reactivity of low rank coal char is attributed to the more active sites, higher porosity, and higher calcium content of the ash. Due to these properties, high reactor space velocities can be used, resulting in lower capital cost in gasification sector. Oxygen and steam consumption can be reduced, and high carbon conversion can be obtained. Moisture and oxygen content. The high moisture content of low rank coals acts as diluent in the gasification process. Fixed bed gasifiers can accommodate up to 35% of moisture content, Fully internal and fluidized bed gasifiers can accommodate less than 5% of moisture content. Oxygen content behaves Properties of oxygen content behaves similar to the moisture content. Volatile control. The chemical composition of the volatile substances produced from low-rank coals during the gasification process is different from high-rank coals. So, therefore, separate treatment and utilization of these products will be different in plants using low-rank coals. In fixed bed gasifier, a large amount of tar, oil, phenol, and other volatile compounds are produced, while in fluidized and internal bed systems, which are operating above 800 degrees Celsius, such volatile compounds are cracked into carbon and hydrogen, so thus there is no need for separate treatment. Caking properties. Most bituminous coals tends to swell and accumulate when heated between 350 to 550 degrees Celsius. These type of coals can be gasified without any problem in an internal bed gasifier where particle interactions are minimized. However, in fixed and fluidized bed system, there need to be some pre-treatment. Low rank coals do not have kicking properties and can be processed without pre-treatment in all types of gasifiers. Types of gasifiers. Depending upon the medium of gasification, they are classified into two types, air blown and oxygen blown. Depending upon the contact between gas and fuel, they are classified into three types, moving or fixed bed gasifier, fluidized bed gasifier, internal bed gasifier. Moving or fixed bed gasifier. Fixed bed gasifiers are characterized by a bed in which coal moves downwards. The coal is supplied at the upper part while the residue is removed at the lower part, and this provides support for the bed. The coal moves countercurrent to the rising gas stream through four different zones: drying zone, gasification zone, oxidation zone, ash zone. Some of the characteristics of fixed bed gasifier: simple in configuration and operation, high equipment efficiency, relatively low oxidant requirement, less complex feedstock of preparation, feedstock that is suitable to handle coal with high reactivity and moisture, high methane content in the product gas. Fluidized bed gasifier. In fluidized bed gasifier, the bed of solid particles behaves as fluid. In this type of gasifier, feedstock of particles size less than 5 mm is suspended in oxygen-rich gas. The rising gas reacts with feedstock and maintains the fluidized state of coal particles. A uniform temperature distribution is obtained in the gasifiers. They have high carbon conversion rate of 90 to 95%. The operating temperatures are usually less than as fusion temperature, so as to avoid clinker formation and the possibility of defluidization of the bed. Some char particles are entered in the raw gas and they can be recovered and recycled back to the reactor with a cyclone. Some properties of the fluidized bed gasifiers are load flexibility and high heat transfer rates, fuel flexibility, moderate oxidant requirement, uniform moderate high temperature throughout the gasifier, excessive char is recycled. Internal bed gasifier. In internal bed gasifier, coal particle size less than 0.12 mm is entrained with gasifying agent to react in co-current flow in a high temperature flame. The full entrained particles require relatively high gas velocities, and this leads to high output and less residence time. The gasification reaction occurs at a very high rate and carbon conversion efficiencies are very high. The tar, oil, phenol and other liquid produced from devolatilization of coal inside gasifier are composed into hydrogen and carbon dioxide. Internal bed flow gasifier have ability to handle capacity of any coal feedstock and produce clean tar-free syngas. Internal bed gasifier melt coal ash into inert slag because of high operating temperature. Internal flow gasifier characteristics: fuel flexibility, large oxidant can either be oxygen or air blown, uniform temperature within the reactor, short reactor residence time, high carbon conversion, high level of sensible heat in the product gas. So now let's see operating parameters for different types of gasifiers. Cool feed phase. In fixed bed gasifiers, we need less than 50 mm, in fluidized bed less than 6, and in internal flow gasifier less than 0.1. As contents, there is no limitation in fixed bed gasifier, no limitation in fluidized gasifier, but there is some limitation less than 25% in internal flow gasifier. Operating temperature for co-current fixed bed gasifier 700 to 1200 degrees Celsius, counter-current fixed bed gasifier 700 to 900 degrees Celsius, in fluidized bed gasifier less than 900 degrees Celsius, in internal flow gasifier 1500 degrees Celsius. Exit gas temperature in fixed bed gasifier 420 to 650, in fluidized bed gasifier 920 to 1050, in internal flow gasifier 1200. Tar content, low tar content in fixed bed gasifier, medium in fluidized bed gasifier, totally absent in internal flow gasifier. Main characteristics: hydrocarbon liquid in the raw gas. In fixed bed gasifier, in fluidized bed gasifier, large char is recycled. In internal flow gasifier, large amount of sensible heat in the raw gas. Technical issues with fixed bed gasifiers are limited ability to handle coal fines, long feedstock residence time in gasifier. In fluidized bed gasifier, technical issue is carbon conversion. In internal flow gasifier, technical is raw gas cooling. Thank you.